That light right there has been running for 11 hours. The battery powering it, I pulled it out of the recycling bin 3 days ago. My daughter's toy rejected it. The TV remote rejected it. My flashlight rejected it. Every device in this house told me that battery was dead. It is not dead. It never was. And a $4 circuit is the reason that light is still on. Here is something the battery industry does not want printed on the side of the box. When your device tells you a battery is dead, that battery still has between 60 and 70% of its original energy left inside it. Not a little bit, 60 to 70%. A brand new AA battery starts at 1.5 volts. Your remote control, your flashlight, your kid's toy, they stop working when the battery drops to around 1.2 volts. The device refuses to run. You assume the battery is finished. You throw it away. But 1.2 volts is not empty. It is barely used. The energy is still in there. The device just cannot access it because modern electronics are designed with a voltage floor. Below a certain point they shut off. Not because they have to, because that is how they were engineered. Duracell sold $2.9 billion worth of batteries last year. Energizer sold $1.8 billion. Every one of those batteries gets thrown away at 1.2 volts, with most of its charge intact. 3 billion batteries per year in the United States alone, going into landfills still full of energy. They know exactly what they are doing. If you have never heard of a Joule thief before, hit like right now. Because this is the circuit that battery engineers know about, and nobody at Duracell wants showing up in your search results. The Joule thief has been around since the 1990s. The name was coined by an engineer named Z. Kaparnik in a 1999 electronics journal. The concept is older than that. It is based on a switching circuit that boosts low voltage into usable voltage fast enough to power LEDs continuously. Here is the simple version of how it works. Your dead battery is sitting at 1.2 volts. An LED light needs between 1.7 and 3.5 volts to turn on. The gap between what the battery has and what the LED needs is why the light will not turn on if you wire them directly together. The Joule thief fills that gap. It is a circuit that rapidly switches the battery current on and off thousands of times per second. Each time it switches on, it stores a tiny charge in a coil of wire. Each time it switches off, it releases that stored charge as a voltage spike. Those spikes are higher than the battery voltage, high enough to power the LED. The circuit does this so fast that your eye sees continuous light instead of thousands of flickers per second. It is the same principle behind the boost converters inside every phone charger and laptop power supply. The difference is that those cost $40 and this costs $4. Here is what you need. Write this down. 12N3904 transistor. This is a standard NPN transistor that costs about 30 cents at any electronics store or less than $1 for 10 on Amazon. 1 kilo ohm resistor, brown, black, red, costs 10 cents. 1 ferrite toroid ring. This is the coil core. Size does not matter much for this application. Any small ferrite ring works. You will find them inside old power supply boards, inside dead computer fans, inside any electronic device you are about to throw away anyway. Or buy a pack of 10 for $2 online. 24 inches of thin magnet wire, the kind with the enamel coating, usually comes with electronics kits. If you buy it separately, it costs about $1 for more than you will ever use. 1 LED, any LED, warm white, cool white, colored, it does not matter. Pull one out of a broken string of Christmas lights. They work perfectly. Total cost if you buy everything new, $3 to $4. Total cost if you scavenge components from old electronics you are going to throw away, $0. Here is how you build it. This is the part most videos make complicated. It is not complicated. Take your ferrite toroid ring, wind 12 to 15 turns of magnet wire around it going in one direction. This is your primary winding. Leave about 3 inches of wire on each end. Now wind another 12 to 15 turns going in the same direction as the first. This is your secondary winding. Same number of turns, same direction. Leave 3 inches on each end again. Scrape the enamel coating off all 4 wire ends using sandpaper or the edge of a knife. The wire underneath needs bare metal contact. 30 seconds of light scraping on each end. Now connect them. Take one end of the primary winding and twist it together with one end of the secondary winding. This becomes your positive connection to the battery. The other end of the primary winding goes to the base pin of your transistor. That is, the middle pin on a 2N3904 when you are looking at the flat face. The other end of the secondary winding goes to the collector pin. That is the right pin when facing flat side toward you. Your 1 kilo ohm resistor goes between the base pin and the emitter pin. Emitter is the left pin. The LED positive leg goes to the collector. LED negative leg goes to the emitter. Connect a dead AA or AAA battery. Positive to the twisted wire junction, negative to the emitter. The light turns on. That is the entire circuit. 7 connections, 4 components. Runs from a battery, every device in your house already rejected. Now let me show you what this actually powers, because most people assume this is just enough for a dim flicker. A single Joule thief circuit running one high brightness LED produces enough light to read by in a dark room. Not emergency candle light, actual reading light. I have had one running on a single dead AA battery for 14 hours before the light finally dimmed. Run 2 or 3 LEDs in parallel off one circuit, and you have a light source bright enough to illuminate a small room during a power outage. Scale up to 3 circuits running off 3 dead batteries wired in series, and you have enough light to work by in a garage or basement with 0 utility cost and 0 expense beyond $4 in components that last indefinitely. The circuit itself never wears out. The transistor and resistor have no moving parts. The only thing that eventually depletes is the battery, and when the battery finally reaches true zero, around 0.6 volts, you swap in another dead battery from your recycling bin and start again. You are running on energy that was already paid for and already discarded. The power company sees none of it. The battery company sees none of it. It is already yours. One more thing that most people do not put together until they think about it. This circuit works on any small battery. AAA, AA, C, D, 9 volt. It works on rechargeable batteries that no longer hold enough charge for modern devices. It works on the lithium coin cells from watches and key fobs that electronics stores charge $4 each to replace. Those coin cells sitting in your junk drawer right now, the ones your watch rejected, still have enough charge to run a Joule Thief LED circuit for 6 to 8 hours. You have been throwing away hours of free light every single time. Drop in the comments and tell me what dead batteries you have sitting around right now. AA pile from remote controls, D cells from flashlights, 9 volts from smoke detectors. I want to know what you are working with because the circuit scales differently depending on battery type, and I will give you the specific configuration for whatever you have on hand. If this video just changed what you do with your recycling bin, hit subscribe. Every week I put out something the industry has been quietly hoping you never find. Last week it was the $4 borax box that replaces $200 of cleaning products. The week before that, the $3 powder that keeps snakes out of your yard permanently. They built a world where you throw away energy you already paid for. We are done doing that. Earl out.